Hello, today I'm going to go over the standard deviation practice, and it talks about what standard deviation is here and give some examples of why we use it. But when we talk about standard deviation, we want to start with the mean. So if this is our mean here, standard deviation, there's one standard deviation, two standard deviations, and three standard deviations. And that goes both sides of the mean. What the standard deviation is though, if we talk about one standard deviation away from the mean, 68% of your data will fall within here. Two standard deviations, and that's 95% of your data. And then three standard deviations is going to be 99% of your data. And it just gives us an idea of how closely grouped our data is. So a small standard of deviation, if it's very close to the mean, if the one standard deviation is very close to the mean, that means most of our data, 68% of our data, is all very close to the mean. If the standard deviation was much larger, so one standard deviation out was a larger number, that means our data is all scattered about. It's very widely dispersed. The numbers are not close together. So we're going to take a look at some of this. Now, we're not calculating standard deviation. That would be a normal practice in a stats class. It's not that difficult, but it can take a while. Not something we want to do here. I just want you to start getting used to this concept of standard deviation. So the first thing you're going to do on all of these examples, here, here, and here, is you're going to write where the mean is. So in this first problem, the mean is 55, and it's this symbol here is where we write it. It's right in the middle. And then it says standard deviations of 10. So that means going this way, 10 more than 55 is 65. 10 more than 65, 75, and then 85, right? And then this goes in the opposite direction, going lower. 10 lower than 55 is 45, then 35, then 25. And I got that because of that standard deviation of 10. Okay. Now, it presents a scenario here where it's tracking Monday through Sunday. Here's how many pastries were sold over the course of the week for each day. Would a sales day with 60 sold pastries be likely or unusual? Well, 60 is right here, and we know that's within our first standard deviation, which is about 68% of our data. So that's pretty likely. You know, that's not an unusual number. 60 would not be an unusual number of pastries to sell because it's within this first standard deviation. So this would be likely. Would a sales day with 25 sales be normal? So out here at 25, 3 standard deviations away. Is that pretty likely to happen? No, it's pretty unlikely. I mean, this range right here is 2%. And if you're beyond that range, less than 1% of your data is out that way. So 25, way at the ends here, at the extremes, that's going to be not normal. Give an example of how many sales would make a rare and very good day. So very good day is obviously higher than the mean, and rare is something that we wouldn't get, a number we wouldn't get very often. So 60 is going to be that'd be a typical day. That wouldn't be rare. But out here is where we start to find these rare days. So your number may vary. Maybe it's 85, maybe even 75. Or in this case, like what I'm going to write down is I'm going to write down right in the middle, 80. Or maybe it's above 80, maybe say 90. That would be rare and a very good day. So there's different answers for that one. Now you're going to do the same thing with all the rest of these. You want to mark all of these graphs. So like my mean is 29. My standard deviation was 2.27. So all I did was take 29 plus 2.27, and that gave me 31.27. Write out the rest of the standard deviations and then answer the questions. All right? Let me know if you have any questions, and thank you very much.